Hello, ladies and gentlemen. Today we're going to look at population and Leslie matrices. Let's start with this first example, which says, suppose a new species of pig, Sus guineus, in a small region had the following populations. And now, this chart on the left gives you a birth rate and for each age group and a survival rate for each age group. And this chart right here gives you the corresponding population of each age group. Okay. Part A says to calculate how many 0 to 2 year olds there will be in the next 5-year cycle. Okay. All right, so the first thing we're going to do is we're going to take 30, which is the 0 to 2 age group, and multiply it times its birth rate. All right, so that would be 30 times, the birth rate there is 0.0 or 0 if you like. We're going to add to that 25, and that's the 2 to 4, and theirs is also 0. Apparently they're not having any babies, okay? Plus the 4 to 6 year olds, there's 26 of them, and they will have a birth rate of 1.2, so we would multiply that by 1.2, all right? And then we would take the 28, so plus 28, and that would be, that's the 6 to 8, so that'd be times 0.7, okay? Plus, all right, we would then take the 22, which is the 8 to 10, 22, 8 to 10, and multiply that times 0.6, plus the 15 that are 10 to 12, and multiply that times the 0.05. Okay, all right, now I'm just going to put all that in a calculator real quick, and we'll figure out exactly what that's equal to. Well, 30 times 0 is 0, and that's 0 as well. I'm not going to bother with that. So, oops, excuse me. Let's just do, I'm going to clear this RAM for a second here. Let's do all RAM. We'll clear the RAM, reset it, all right, and that way we won't have any problems. So these first two products are 0, so there's no need messing with those. So once this thing clears, we'll just type in 26 times 1.2 plus 28 times 0.7 plus 22 times 0.6 plus 15 times 0.05. All right, and when we come back, that gives us 65.75. Okay, so this is equal to 64.75, or if you want, you could round that off to 65. Okay, all right. Next, it says to complete the table for the next cycle and show your steps. Okay, well, for the next cycle, this number right here will be the population in that 2 year. Now, cycles go from this to that many years. That's 2 years, okay? All right, so the next year after 2008 would be the 2010, all right? And that means that that number, 64.75, would go here, okay? All right, and now we're going to take, for the next number here, we're going to take this 30, all right, and we're going to multiply it times the survival rate of that group. That was the 0 to 2. That survival rate is 0.6. So 60% of those survive. All right, and if we did that, 30 times 60% is 18. So 18 here. All right, and then we're going to take the 25 right here and multiply it times the 0.85. Okay, all right, so 25 times, not divided by, times 85% of those guys are going to survive would be 21.25. Okay, all right, 21.25. And then we would do the 26 right here times its survival rate, 0.9, 0.9. Or 90%, 90% of 26 is 23.4. Yeah, that went down here. All right, 23.4. All right, and then we would take the 28 right here and multiply it times the survival rate for the 6 to 8 year olds, which was 80%, so 0.8. All right, and 28 times 0.8 would give you 22.4. Okay, that goes here. All right, and then next we're going to take this 22 right here and multiply it times the survival rate of 1/2, or 0.5. Half, that's 11. All right, and that would go here. And of course, for the 15, 0% of those are going to survive. I guess they're going to die off or get killed or whatever. Okay, all right, so we won't bother with that. All right, now the next part says to go down and complete the table for the next cycle. Okay, so the next cycle, all right, there would be this many 0 to 2-year-olds, 64.75, all right. There would be 18 of these, 21.25 of those, 23.4 of those, all right, 22.4 of those, and 11 of these. Okay. All right, and now we're going to figure out the rates of these, okay? All right, so for the number of babies here, we're going to do the same thing we did up here. All right, we would take the 64.5 times 0 plus, all right, excuse me, let's see, where are we at? 18, all right, 18 times 0 plus the 21.25, all right, times 1.2, all right, plus the 23.4 times, that's 68.7, all right, plus the 22.4 times 0.6 to get, all right, plus the 11 times 0.05. All right, so let's put that in, and that'll be the number that we put right here, by the way, okay? All right, so let's figure out, well, these first products are useless, so we would take 21.25 times 1.2, all right, and that would give us about, we got to add to that, excuse me. I'm going to do all of that calculation. 21.25 times 1.2, all right, plus 23.4 times 0.7. Now, if you rounded these to the whole numbers, that would change things slightly, but it wouldn't change things a lot, I will tell you that. I don't like to round, so I'm not going to. It doesn't matter at this point. So 21, let me see where I'm at here. 21.25 times 1.2, I did that, plus 23.4 times 0.7, plus 22.4 times 0.06, plus 11 times 0.05. Okay, and when we hit enter, we're going to end up with about 43. All right, that don't seem right. We should have a little more than that, I think. Let me double check that again. All right, so if we took 21.25 times 1.2, I'm just going to recalculate to make sure, plus 23.4 times 0.7, okay, plus 22.4 times 0.6, plus 11 times 0.05. Oops, I didn't do times. Excuse me, 11 times 0.05. Okay, there we go. That's a little bit better. All right, and we'll write that down here. So 55.87. All right, and then what we would do next is we would say, okay, of these 64.75, only 60% would survive, so we would do 64.75 times 60%, and that would be the number that goes here. Okay, so 64.75 times 0.6, and that would be about 38.85. 38.85. And then we would, and that number came from here, so we're going to take this number 18, and we're going to multiply it times the survival rate for the 2 to 4-year-olds, which is the 0.85. Okay, so times 0.85. All right, let me clear this off. 18 times 0.85. and that would give us 15.3. All right. Next, we will take the 21 1/4, all right, which was the 4 to 6 year olds. Their rate is 90% of survival. All right. So we would type in 21 1/4 times 90%, okay, and that would give us 19.125. All right, and then we would take 23 4/10, which is the 6 to 8 year olds. They survive at a rate of 80%, so that's times 0.8. So 23.4 times 0.8, and that would give us 18.72 for that quantity. Okay, and then, excuse me, we would then take 22.4, and that's 8 to 10 year olds. They survive at a half, at 50% is, 80%. Okay, at 1/2, so that's times this should be a decimal there, 0.5. So 22.4 times 0.5 is 11.2. 11.2. Okay, all right, so there's your cycles. All right, let's turn the page. Now, we're going to do this problem again, but this time we're going to use matrices, and we're going to use what's called a Leslie matrix, okay? Leslie is the name of a very famous mathematician that came up with this information from populations, and this, assumes that there's no external influences on the environment, whatever population you're dealing with. And here's what we do when we do a Leslie matrix, okay? All right, this is the word Leslie, L-E-S-L-I-E, matrix. All right, the Leslie matrix has the rate of growth in the column 1, and then starting in column 2 and going on a diagonal, you have the survival rates, okay? So those are your rates of growth right here, and then this is diagonal coming down is your survival rates. And it will always be a square matrix. And if you have groups of however many groups there are in groups, you'd have a 1 by n, and this would be your initial population matrix, P sub 0, and L would represent your Leslie matrix. Okay, all right, so let's go over here and let's actually create the initial population matrix and the corresponding Leslie matrix. Okay, all right, so if we do that, P sub O, the initial matrix, would be equal to, all right, there are 30, 25, 26, 28, 22, and 15. All right, so there is your population matrix. Now, the Leslie matrix, okay, all right, we'll have it's going to be a 1, 2, 3, 4, 5, 6 by 6 matrix. Okay. All right. So it's going to be a very large matrix. All right. 6 by 6. And the first column will be your birth rate. Okay. So you first column here, your entry is 0. That came from right here. The next one is 0 right here. The next one is 1.2. Okay. The next one is 0.7. The next one is 0.6, all right, and the last one is 0.05. That's your birth rate, okay? That first column will always be your birth rate. And now we're going to start with the row 1, column 2 entry, all right? That would be your survival rate for the initial age group, okay, which is 0.6. So 0.6, all right? And then we're going to need 6 out here, so there's going to be 4 more zeros. 1, 2, 3, 4, okay? Because it's got to be a 6 by 6. This is going to be a 1 by 6, and this has to be a 6 by 6 down here. That's one thing you need to remember, okay? All right, and then this is 0, 0. The next one is the second survival rate for the second age group, which in this case is 0.85. All right, and then there will be 1, 2, 3 zeros. All right, you'll have a 0 here, and then the next rate is 0.9, so 0.9, and then 2 zeros, because you've got to have 1, 2, 3, 4, 5, 6 entries in each row and 6 entries in each column. All right, so then 2, 3 zeros, all right, and then the next survival rate was 0.8, so the 0.8 goes here, and 1 0 out there. Okay, and the next row, the fifth row, would have 1, 2, 3, 4 zeros, and this percentage right here will go here, and then everything else will be zeros, ladies and gentlemen. Okay, and that's how you create your Leslie matrix. All right, now, the next thing it talks about is how many Leslie cycles would have been completed by the year 2010. Well, this thing starts in 2008. So we're going to take 2010, whoops, that's a 0, 2010. We're going to subtract the initial date that the data came from, which was 2008. And then we're going to divide by, and this is what's very important, all right, that number, whatever the end of that first period there is, goes down here. Okay, so 2. All right. Well, if we subtract 2008 from 2010, that's 2, and when we divide that by 2, we get a 1. So there is one cycle, one Leslie cycle from 2008 to 2010. Okay, all right. Now, Part C says, use your calculator and the matrices created in Part A, the initial population matrix and your Leslie matrix, okay? All right. Of this question, to determine the population of, I believe this should say pigs for the age group in each year of 2010. Okay, well, the first thing we need to do is put our population matrix in, all right? So I'm going to get my calculator, and I'm going to say, okay, all right, let me slide over where you can see everything pretty good. All right, second matrix, all right, I'm going to edit, and if you want, you can call this population matrix A, okay, and we'll do B here, since our calculator doesn't really have letters that we want, we'll just make them what we want them to be. Okay, so we're going to edit. This first matrix is a 1 by 6, okay, and there's 30 in the 0 to 2 age group, 25 in the 2 to 4, 26 in the 4 to 6, 28 in the next one, 22 and 15. Okay, now if I was doing this, I would do second matrix 1 and see if I make sure I got all those right. 30, 25, 26, 28, 22, all right, and 15. That's good, okay. All right, I'll just clear that out. I go back into the matrix editor, go to edit, and we're going to edit B. We're going to put in B. B is a 6 by 6 matrix. Okay, so row 1 starts with a 0, all right, 0.6, you don't have to hit the 0, and then 4 zeros. 1, 2, 3, 4, and you can just keep hitting 0 and 0. Now we'll go to row 2. All right, that's 0, 0, you don't have to hit the 0 again, 0.85, all right, and then 3 zeros. 1, 2, 3, and then row 3, we have 1.2, 0. All right, let me get this where you can see it a little better. 1.2, 0, and then 0 again, and then 0.9, whoops, not 1, 0 and 0 again. Okay, all right, row 4 is 0.7, 0, 0, 0, 0.8, and then 0. Row 5 is 0.6, and then 1, 2, 3, 4, 5 zeros. And then finally, row 6 is 0.05, and then 1, 2, 3, 4, 5 zeros. Okay, now you might want to go back and double check and make sure this last column is all zeros, which it is. Make sure that that next column, we can check the whole, begin at the first column. All right, first column, 0, 0, 1.2, 0.7, 0.6. That first column looks good. 0.6, and then the rest zeros is good. 0.85, and the rest zeros. All right, and then 0, 0, 0.9, and then 3 zeros. And then the last one, next to the last column is 3 zeros, 0.8, and then 2 zeros. And that way you can double check real quick to make sure you've got those in. Okay. All right, now it said next to do this multiplication. Well, what that means is we're going to do our population matrix, piece of initial, times our Leslie matrix, and that will give us this one right here. Now, we need to make sure we know the right cycle. How many cycles? Well, from 2008 to 2010 we figured was one cycle, because this Leslie matrix gets applied each time you complete a cycle. Okay, all right, so we would just have one cycle. That means that Leslie matrix is going to be just used once, so we're going to do second matrix 1 to get that population matrix, and then we're going to do second matrix 2 to get that Leslie matrix. And when we do, it's going to come back and give us the first one that we had on the other page. If you remember, it was 64.75, 18. All right, here I'm going to slide over where you can still see it. Okay, 18 from 2 to 4. All right, and then it had 21.25. All right, and then from 6 to 8, you can't see it, but if you just move to the right, it's 23.4. 23.4. And then 22.4 is the 8 to 10. And then if you keep going to the right, 11. Did we put something in wrong? Okay, let me check my matrix here, because that number's not coming up right. That probably means, let's see, oh, we forgot a 0.5 right here. This one should be 0.5. Okay, so let me go back and fix that. That's not going to change a whole lot, I'll tell you that right now. Let me go back and edit that matrix. Second matrix, let's go edit. That's the 6 by 6. And that last column, all right, I'm going to go down to that last column, all right, and it should be, that last column should have a 0.5 right here. So 0.5 or just 0.5. All right, and then I'm going to call that back up, that product, and it's going to give you basically the same thing if you look at it, except for now we're going to get the 11 in the 10 to 12 category. And if you forgot, the reason I remembered that was because when we did it a minute ago, you can see that that number right there is the same as this one, and that number same as this one, and so on. You can just compare those, okay? All right, if you did it by hand. Now, how would you suggest estimating how many pigs were in each group age in the year 2011? Well, we could apply that Leslie matrix one more time, okay? All right, so we'll write that down. We could apply the Leslie matrix, oops, I need IE, matrix again. Okay, all right, that's what we could do. All right, and by the way, you can do it one of two ways. You can do piece of the initial, all right, times the Leslie matrix squared, or you could do, by the way, you might want to call this piece of 1, that matrix right there, piece of 1 times the Leslie matrix again. All right, you could do it either way. All right, I like to do the power. If that's okay with you, I'll do the power. Okay, all right, so let's do that. Okay, actually, I'm going to show you both so that you see that you should get both. And what I'm going to do is I'm going to hit store, and I'm going to do second matrix. I'm going to store that in 3, in C, okay? And now, if I did, I'm going to do it this, I should get the same thing both ways. Let's do the initial matrix, the initial population matrix, which we put in A, times the Leslie matrix, oops, I don't need that, get that out of here, times the Leslie matrix, but we're going to square that matrix, okay, so that we apply it times again. All right, when we hit enter, we should get the same thing that we would have gotten if we had done the third matrix, second matrix 3 times that Leslie matrix again. all right, which is 2, we should get the exact same numbers, and you can see we do 55.87, 38.85, and so on. Okay, so you can do it either way. It would give you the number in 2011, all right, and what that would give you, all right, would be, let's see, let's just write that matrix down. So the population, all right, in 2011, all right, would be 55.87 for the, oops, I don't need a comma there, for the 0 to 2-year-olds, okay? All right, that's 0 to 2, all right, and then let's see, what was that next number? 38.85, 38.85 in the 2 to 4-year-olds, all right, and then 15, oh, I went too fast, 15.3. 15.3 in the 4 to 6-year-olds, and 19.125 in the 6 to 8-year-olds. Okay, all right. And in the 8 to 10, we would have 18.72, right? Okay. 18.72, 18.72, oops, that's a 2. And then 11.2 in that last one. All right, and if you wanted to put 0 to 2, what is this? 2 to 4, excuse me. 2 to 4, I don't need that. And then 4 to 6, and then 6 to 8, and then 8 to 10, and then 10 to 12. I guess these pigs don't last too much longer than 12 years. Okay, all right. What would be your, for the year 2000, using your suggestion from Part B? Oh, we did that. Our work is done already. All right, why is it necessary for that survival rate of the last group be 0 for this model to work? Well, there's many reasons, because if you don't have a 0 at the end, and I'm talking about this survival rate right here, at some point they have to all of the species have to die out. Otherwise, the population would increase forever. Okay, if none of them ever died. Okay, that's what I would write. So without a death, a final 0 survival rate, the population would increase forever. Okay, so without a final survival rate of 0. All right, of 0, the population would grow forever. All right, that's why. All right, turn the page. New problem. Problem number 2 says, suppose that a certain species of elephant has characteristics as described. Well, here they give you age groups, okay, and it looks like they last up to about 35 years, all right? And over here they give you birth rates and survival rates, okay? And the first question, part A, says, all right, to calculate how many 0 to 5-year-olds there will be in the next 5-year cycle, okay? Well, let's do that by hand once again. All right, so we would take 20, all right, and multiply that times the birth rate, first of all, 0, all right, and that would give us, 0, by the way, but we'll deal with that in a minute. 30 times 0.1 plus 10 times 0.4, all right, plus 30 times 0.9 plus, I'm running a room, so I'm going to come down here and do the rest of it down here, 12, which is the times 1.1, all right, plus 10 times 0.3, all right, plus 6 times 0. Okay, so that first and last product are zeros. I'm not even going to bother putting those in the calculator. They're not going to change the quantity at all. All right, so I'm just going to put those others in. I would have let me first of all clear everything. All right, and then I would type in 30 times 0.1. Okay, all right, plus 10, all right, we're right here, times 0.4, times 0.4, 40% of those, plus 30 times 0.9, all right, plus 12 times, what is that, 1.1, okay, plus 10 times 0.3. All right, so when I hit enter, I get 50.2. So we're looking at about 50 of these elephants for this particular 0 to 5 years old. Okay, all right. Complete the table for the next cycle and show your steps. Okay, so we're going to show our steps. All right, for the next cycle, this number right here would be this number right here. It comes and goes right there, okay? All right, and to find this number, we would take 20, all right, and multiply it times the survival rate, all right, which was 0.5. Okay, that's coming from the survival rate for the 0 to 5 year olds, so about half of them, okay? And of course, half of 20 is 10, okay? So that's what goes here. Then we would take 30, all right, and multiply it times the survival rate for the 5 to 10 year olds. Well, that's 0.7, so 0.7. Well, that'd be 21, okay? So that would be 21, all right? So then we would take 10 and multiply that times the survival rate for the 10 to 15 year olds, which would be 0.8. 0.8, and that would be 8, okay? All right, so then we would take 30 and multiply that times the survival rate for the 15 to 20 year olds, which would be 0.7, all right? And that would be 21, okay, all right? And then we would take 12 and multiply that times the survival rate for the 20 to 25 year olds, which would be 0.6. That's 7.2, okay? All right, 7.2. Then we would take 10 and multiply that times the survival rate for the 25 to 30 year olds, which would be 0.4. And that would be 4. All right. And if you did the other one, 6 times 0 would be 0 over here if you needed to write it over here. Okay. If you wanted to, you could. All right. So there's the work that we did. Okay. Part C says to create the initial population matrix and the corresponding Leslie matrix. Okay, so let's do the initial population matrix over here, P sub 0, all right, and it was 20, all right, 30, 10, 30, 12, 10, and 6. All right, so that's 1, 2, 3, 4, 5, 6, 7. So that's a 1 by 7 matrix, all right? The Leslie matrix will have to be a square matrix with this number of rows and columns, okay? So it's going to be a very large matrix. Okay. All right, so we'll make that Leslie matrix up here. All right, now please remember that your birth rate will be column 1. So that first quantity is 0, 0.1, all right, 0.4, all right, 0.9, that's 1, 2, 3, 4, and then 1.1, all right, and then 0.3, and then the last one is 0. Okay, all right. Now, this row 1, column 2 entry will be your first survival rate, 0.5, okay. And now I've got 2 entries in that row, and I need a total of 7 so that I can get a 7 by 7 over here because I'm going to multiply. And if I'm going to multiply, these 2 quantities have to be the same. Please remember that. And these 2 quantities will always be whatever this number is right here. So I need 5 more entries there. So that means I'm just going to put zeros. 1, 2, 3, 4, 5. Okay. All right. So now the second survival rate will go on a diagonal, all right, right here. All right, so not under that 5.5, but under that 0 right there. So 0.7 would go here. That's 1, 2, 3 entries. I need 1, 2, 3, 4 zeros to get my 7 there, to get my Leslie matrix. Okay, so then I would do another 0, and under this 0 would be the 0.8. So 0.8. Okay, all right, and then 3 more zeros. All right, I need 1, 2, 3 zeros here, and under that 0 will be 0.7. Okay, and then 2 more zeros. All right. Let's make sure 1, 2, 3, 4, 5, 6, 7. Yes, I got it right. Okay, so I'm going to need 4 zeros this time. 1, 2, 3, 4. And then I'm going to need 0.6 and then a 0. All right. And then I'm going to need 0, a 0, a 0, a 0, and a 0. And don't forget that 0.4 this time. Okay. All right. And every time you should know by now that this last one is going to be all zeros unless there's something right here. All right. Okay. All right. So there is your Leslie matrix. Okay. All right. Now, how many life cycles would have been completed by the year of 20,025? Okay. Well, this thing started in year 2000, so we're going to find 20,025 and subtract this 2000 up here, because that's when the data started. Okay, and then we're going to divide by this number right here. That's very important. The end of this first age group here, all right, is what goes here. That wasn't the same the last time, so keep that in mind. Okay, and this will tell us how many cycles this Leslie matrix would need to be applied to this population matrix. Okay, well, when we subtract 2,000 from 25, that's 25. And if we divide that by 5, that tells us there are 5 cycles that we would need to apply. All right, or if you like, you can use this matrix to the 5th power when you multiply it times this one. Okay, all right, if you wanted to find a population for that year. Okay, in fact, that's what we're going to do next. We're going to take our population matrix, their initial population matrix, and we're going to multiply it times the Leslie matrix to the 5th power, because it does say what's going to happen in the year of 2025. Okay, so now let's put these matrices in. All right, and I just like to clear my RAM real quick. I don't want to mess with what's in there, so I'm going to go in. I'm going to say, okay, the second matrix, and I'm going to put in the population matrix. It's a 1 by 7, and I'm going to put it in A, if that's okay with you. All right, so enter a 1 by 7. All right, and it's a 20 by 30, or 20, 30, 10, 30, 12, 10, 6. Okay, now I'm going to go back and double check. 6 is row 1, column 7, 10, 12, 30, 10, 30, and 20. And I've got it in there correct, so I'm going to go second quit. And I'm going to do second matrix. I'm going to edit, and I'm going to edit number 2. It is a 7 by 7. Ooh, that's a lot. All right, row 1 is 0, 0.5, and then 5 more zeros. 1, 2, 3, 4, 5. Row 2, all right, is 0.1, 0, 0.7, okay, and then 4 zeros. 1, 2, 3, 4. If I'm not back at the first column, I'll know I've done something wrong. I'll go back and check it, okay? All right, row 3 has 0.4 as its entry, and then 2 zeros, and then 0.8, and then 1, 2, 3 zeros. I should be back over here ready for row 4. All right, row 4 starts with 0.9, has 1, 2, 3 zeros, 0.7, and then 2 zeros, and I should be back over here ready for row 5, all right, and that starts with 1.1, then it has 1, 2, 3, 4 zeros, so 1, 2, 3, 4, and then we have a 0.6, and then 1 more 0. I should be ready for row 6. Row 6 starts with 0.3, has 1, 2, 3, 4, 5 zeros, and then 0.4 at the end, okay? And then the last one is 0.3, and, oops, I'm not in the last one, am I? Oh, has 0, excuse me. Good thing I looked. Zeros all the way across, okay? 0, 0, 0, 0. There we go. Okay, and you can double check, make sure that this last column over here has 0.4 down here in row 6, column 7 entry. Okay, that's the only entry there. Row 6 only has 0.6 in it right there. row 7 should have, other than the zeros, of course. All right, and then row 8 should have the, whoops, that row, and that's not row 8. That's row 1, 2, 3, 4. Looks good. Let's go to row 3. We should have 0.7 up here. All right, and this one should have a 0.1 at the top and all zeros below that. And then that should be your survival rate column, and I think we've got all that. So we'll do second quit, and then we're going to come over here and we're going to do second matrix. Our population matrix was number 1, and then second matrix we'll get our Leslie matrix, which we put in 2, and then we're going to raise it to the 5th power. All right, and to get it to the 5th power, you press caret and then your 5, your power. Okay, and when you do, it's going to come back and give us that population matrix. And if you noticed, it did a little bit of calculating. That's okay. All right, but that first quantity from 0 to 5 was 26.4581, or if you want to round that to 26, it wouldn't bother me. That second entry, whoops, it went too fast here. Okay, all right, well, let's do this. Let's call that back up. Okay. The second one was 14.05. Where is it? 14.0525. The next one was 10.6295. Oops, I need 6295. All right. That, I'm going to call that back up real quick. I'm going to store that thing because you can store that matrix, all right? If you do store second matrix, I'm going to store it in 3, okay? And then if you call C up, it's a little bit easier to manipulate with it. Let's do C. Okay, well, I thought it would be. There it is right there. Will it not let me go to the end of it? Well, we can do it this way. We'll do second matrix. We'll edit that matrix, okay? Let's edit, and let's edit number 3. And then you can get in there maybe and see those entries a little bit better. Down here, you can see them much better there. There's the first one. There's 14.052. There's 10.6295. The next one would be 11.7208. The next one would be 9.8392. The next one would be 2.352. And then the last one would be 2.8224. Okay. All right. Now, part F asks, it appears that the overall population is declining. If this trend continues, how long or in what year would you estimate the population of all subgroups finally fall below 1 elephant? Okay, well, let's figure out how many powers we would have to do that to. All right, so I'm going to do second quit to go back to the home screen. All right, and at this point, I don't know, I'm just going to have to approximate. So what I'm going to do is I'm going to call up that expression where I multiplied the matrices, and I'm going to change that power from 5 to something a little bigger, okay? All right, let's go maybe to, instead of a 5, let's double that and go to a 10, okay? All right, if we do, what we would want to see is all zeros or negative numbers, and I can see that first entry is not a negative, so 10's not far enough, okay? So let's call that back up, and let's change that 10. Let's double that 10. Let's go to a 20, okay? And let's see if we find a quantity. See, it's gotten smaller in that 0 to 5 year population, but it's not either 0 or negative yet. So let's double the 20, okay? Let's call that back up, and let's double 20, maybe go to 40, okay? All right. If we do, all right, notice it's doing a lot of calculation. Oh, we're getting close. There's a 1. Well, let's go to 50, because I don't want to double 40. That'd go really high. Let's go to 50, okay? And then let's see what we get in 50. Okay. Well, look at it, take some time. Boy, that's really close. That 0.4, I would round that to 0. If you look at that next one, that's round to 0. All right. And if you keep going on down through there, I think, let's store that. Let's store that in C. Whoops, I don't want to do that. I want to store in alpha C. Okay. That was to the 50th power. All right, let's go in and then let's do second matrix and let's see what C looks like now. Let's just call up, let's go edit C, excuse me, 3. All right, those numbers, if we see any of these numbers down here that are, ooh, look, that's all zeros. Oh, basically, if you rounded those are all rounded zeros. So it's definitely between 40 and 50. Let's go halfway, okay? So let's do second enter once, twice to pull that 50, and let's change that 50 to maybe 45, okay? And once again, it's hard to see some of these, all right? So let's look at that, and I'm looking at, I don't know, it looks like that might work. Let's just say it would, okay? I'm not going to argue with you if you probably got a different number, all right? But when I'm looking, if depending on rounding procedures or really, I would say that would work. Or if you want to round that to 1, you might have to back that up to a little more, all right? It all depends. So I'm just going to say about 45 years. So about 45 years would do it. Okay, all right, and if it wants to know, or in what year, that would be 45 years, so 45 cycles, oh, okay, 45 cycles, all right, but remember, there's 5 years in each cycle, so about 45 years, or 45 cycles, excuse me, this is cycles, C-Y-C-L-E-S, and 45 times 5, all right, 45 times 5 would give you about 225 years. All right, so 225 years. All right, and I would add that to the initial information there. So we would be looking at 2,225 approximately. I'm going to write that because you could vary. It all depends on your rounding procedures. Okay, all right, now we're not going to do the bonus. You can look at the bonus if you want. That's on your own. If you have any questions, please show up in a Google Meet, call me, email me, whatever you need to do. Thank you. Have a good day.